All right, I'm going to do a couple of these problems. They should not be too hard. We're talking about proportions and ways of writing them. Right. This first one gives an example: 4 to 7. Give me 4:7. That means a ratio of 4 to 7, or 4 divided by 7. That's actually a ratio 2 as well. So you just mimic this: 54 to 81, or 54/81. So these are easy, right? This one, you just look at this chart: 53 dogs, 11 birds, so it's a 53 to 11. Number of reptiles to number of dogs and cats treated. My reptiles will be what? 4 to what? Dogs and cats. I would put those together. 53 plus 62. Or, I could put it like that. Or, in this case, what would this be? 115, right? So it can be that way too as well. It's pretty straightforward, right? 3 equivalent ratios for the ratio given, right? 2 to 7, or what? You can double this, be 4 to 14, right? Or even triple it. 3 times 2 is 6 to 21. These are equivalent. They're the same thing. Of course, some of them are reduced. So it's the same concept. If someone stick the decimal in there, you can have a little more fun doing the math, right? Write the ratio in the simplest form. 4 to 40, guess what? It's just reduction, right? Divide them both by 4, it'd be 1 to 10. That's all they're saying is reduce it. Okay? 0 to 1,001. Well, it'd just be 0. There's no proportion there. Just let you know, right? That it's kind of an interesting way of going it. The other one says 8 to 6. 8 to 6, right? How can you do this? Well, this could be 4 to 3, right? They're the same. Or you can go 16 to 12. These would all be the same. Of course, I just looked at this one over here. Okay. So now these are not too hard. These are just thinking problems, right? So if they said write the ratios, compare the ratios and put this, right? So 0.5 divided by 20, all right? So that would be 1 to 40. If you basically double it, is that less than 0.04? Well, I know 0.05 is what, a 5 to 20, right? Actually, it's a 1 to 20 relationship. It's a little smaller than that. So this would probably be, as far as a fraction, this would be bigger, right? So and what they did was they just tried to get them to 100 to match it, which is not way you can do it. It's probably much easier than what I was showing you because I had to use my brain. But if we did this one, we just 0.5, and then we had this thing over 20, but we had 0.04. So you convert it to a usable form. This would be 4 out of 100. And this would be multiply these both by 5. That's all we're doing. You end up with 2.5 to 100. So obviously, it'd be like this, 4 to 100. So that'd be the winner for this, right? Let's take this one. Let's take 23, and then you get to play with them on your own, right? It's nice to put these sort of in a usable format, right? So this is saying 3/10. What else is that? 5, 1 to 5 equals 1 to 3/10. Okay, cool. Compare the ratios. That doesn't make sense. Oh, okay. So 1 2/5 over 5, right? And we're comparing it to 3 over 10. All right. That's why we're going to go with it. That's really confusing. I guess they're trying to get you to really think a little strange on that one. In fact, I don't really trust that. I'm actually pulling the book out for that one. Let's see. 6-1. That's kind of crazy. That's exactly what they're doing. What kind of craziness is that? All right, fine, whatever. So this would be what? 7/5, right? And divided by 5 would be times 1/5, right? Equals, in this case, 7 over 25 compared to 3 over 10. Is that right? Yeah, times this by 4. Times this by 4, we would have 28 over 100 compared to 30 over 100. This one would be bigger. Boy, that's a really confusing problem, but that's what they're doing, right? Now, see, this is a little trick. You guys got to look at this. When it's doing this, it's like a fraction. It's 1 and 2/5 over 5, right? And the key to this thing is that you can easily say this divided by 5. So it's going to be 1 and 2/5 divided by 5. You can change that. 5 times 1 is 5, 6, 7. So it's 7/5. Instead of 5, you make it 1/5, right? And now you can do multiplication. And that's where you end up with 7 over 25, right? But this, you can't compare them. It's really kind of hard. This is 3/10. You can't do that. So what I got to do, I got to take 7 over 25, multiply them both by 4, right? That ends up being 28 over 100. And then this one's still 3. You got to multiply these by 10, right? This would be 30 over 100. You can say that's bigger, right? These are all going to be doing that same kind of goofy thing to you, see if you get all spun around. This one, we'd say, is 33 over 100, right? What is this one going to be, right? If you should take that, and we want to put that in a fractional form that we can understand, right? Let's try it. You're going to say, well, that's actually easier than I thought it was going to be. Okay, let's try it. I take 1.7 over 5. I wanted to get to 100. I multiply this by 20. I multiply this by 20. So this times that is what? 20, that'd be 34 over 100. Which one's bigger? Well, 34 over 100. This one is. So I don't want to ruin all your fun because you get to try all these things out, right? And the word problems basically is a matter of reading. Make sure you understand what you're doing. So in 2004 Summer Olympics at Athens, France won 11 gold medals. So I'm going to put France equals 11. 9 silver, gold, 9 silver, right? 13 bronze, 13 bronze. I know you can't read my words, but it's okay. What's the ratio of gold medals to the total medals that France won? Well, let's add them all up, right? So it's 11 plus 9 plus 13 is 33 medals, right? And the ratio would be just gold, 11 to 33. So this is gold to all, right? Thinking problem. So basically it's a 1-2-3 ratio, or 1-3 or 1-3. These all mean the same. Okay. So hopefully this sheds a little light on how to approach these problems when you're doing this section. Okay.